Welcome to Brain Vision.
Let's talk about this question. An adventurous archaeologist crosses between two rock cliffs by slowly going hand over hand along a rope stretched between two cliffs. So this is the rope, and he's going hand over hand like this. He stops to rest in the middle of the rope. This is the middle of the rope, and the rope will break if the tension it exceeds 2.5 times 10 raised to power 4 newtons. And our hero's mass is 90 kg. So this guy weighs 90 kg. If the angle is 10 degrees over here, then what is the tension of the rope, and what is the smallest value of theta, so that the rope is should not break. So let's make a free body diagram over here. These are the two ropes, and they are symmetric about the center since it is at the middle. So let's call this T, and let's call this T as well. And since this angle is theta, so let's make an angle over here. uh, this angle is theta, this is 90, so this is also 90 minus theta, so this angle is also theta. So if this is theta, then this got to be t cos theta, and this is also t cos theta, and over to the top we have t sine theta plus t sine theta, so that's going to be, they will add up, so that's going to be 2t sine theta. And over here the guy hangs, so its weight is exactly down. Now we need to find the tension in the slope, 2t. So we got to equate 2t sine theta with w. We know the value of theta, that's given as 10 degrees, and we know the value of weight, which is mass times gravity. So from here we can get the value of t as 90 times 9.8 over 2 sine 10 degrees. So that's got to be equal to uh, 90 times 9.8 over 2 over sine 10 degrees. So that's going to be uh, 25, that's going to be 2539.62. It's going to be 2539.62. Let me just recheck the calculation over here. So we have 2d sine t is 90 times 9.8. So 90 times 9.8 over 2 over sine 10 degrees. 10 degrees. So that's going to be 2539.62. So it seems like at this particular angle, this is the tension, and this is more than this value. So that's actually at this angle that will break. Now, in a part B, they are talking about whether what is the smallest value of angle so that the tension will not break. So you're going to use the same equation over here as over here. So 2t sine theta is equal to w. The only difference is now we need to find theta such that it will not break. So if it will not break, we are going to replace t by the maximum value. So weight is already 90 times 9.8, and the t is 2.5 times 10 raised to 4, because then that is the maximum allowed weight. So let me grab my calculator again. Over here we're going to get 90 times 9.8 over 2 over 2.5 over 10 raised to 4, and sine inverse of this is going to come out as uh, let me just redo it. 90 times 9.8 over 2 over 2.5 over 1 2 3 4. So that's gonna be sine inverse, and this angle is now coming as, so that's coming as sine inverse of answer is 1.1.01 degrees. This is the required value of theta. And I misspoke in part A. Actually, it won't break because the maximum tension allowed is 2.5 times 10 raised to 4, which is 25000, which is 25,000, and this is just 2000. So in case A as well, it won't definitely break. Thank you.